Okay, ladies and gentlemen, so now it's time for me to show you a different method for factoring a trinomial of this form where a does not equal 1. Now we already know how to do this. When we see something that doesn't have an a equal to 1, we're supposed to common factor, and if we can common factor, then it's going to be easier to do, or we use factor by decomposition. So this is a new way of doing it. It's instead of decomposition, and it's called the Seesaw method. Now, what you do is you take a trinomial that you want to factor. So I'm going to go back to our lesson, factor by decomposition, and I'm going to take 2x squared plus 9x plus 10, and I'm going to go and factor that. Now, I've got a 2 in front. It would be lovely if I could common factor it out. I can't. So what I need to do is either decomposition or the seesaw method. Now the seesaw method is a little interesting. It requires us to realize that our answer is going to look like this. That it's going to be a binomial times a binomial to get a trinomial. And remember, we did that before when we did this question. When I first taught you how to factor, I gave you that and we said, okay, well the answer is going to look something like that. And we said it's going to be an x at the front of both of them to get x squared. Well, this one's a little bit tougher because I know that I can't just have an x at the front of both of them. I need to have something, but I don't know what it is. Well, what you do is you take this number and you put it in the front here and you put it in the front here. Now, if I multiply those, I'm going to get 2x times 2x is 4x squared. Too many 2's. So then we divide by one of the 2. Now, had this been a 5, I would have put a 5 here, a 5 here, and a 5 here. Had this been a 7, it would be a 7, a 7, a 7. What's happening is I'm putting a 7 in front of both of them, and then I'm dividing by a 7. So that gets rid of the extra multiple of 7. And the reason why this is called the seesaw method is because this kind of looks like a seesaw. You get 2 kids sort of sitting here, and you've got this teeter-totter thing happening here. Now, we call it the seesaw method because if you forget to do the teeter-totter, if you forget to put that on, then what you have is just 2 kids sitting on a piece of wood on the grass, and that's kind of silly. So we call it the seesaw method so that we remember it's got to be on top of that pivot. So we got to put the 2, and the 2, and if this was a 5, it'd be a 5, a 5, and a 5. Okay, so that's enough of that. Now, I'm looking for 2 numbers that multiply to give 20. And I'm looking 2 numbers that add to give 9. Well, those 2 numbers are 4 and 5. So we're going to put a 4 and a 5. It's going to be positive for both of them. So I put a positive. And now we got a little bit of work to do. This number on the bottom, whatever it is going to reduce with the top. So I have to find this multiple in the top somewhere. So I look at this binomial and I common factor out the 2. Because there's a 2 in the 2x and there's a 2 in the 4 that can come out. So it comes out as x plus 2. Because 2 times x is 2x, 4. So this was common factored. This doesn't get common factored because I can't take a 2 out of 5. But what I have here is this times this times this divided by this. Well, no sense multiplying by 2 and then dividing by 2. And it leaves me with a final answer of x plus 2 and 2x plus 5. Let's expand and make sure it works. X times 2x is 2x squared. X times 5 is 5x plus 4x plus 10. We get a final answer of 2x squared plus 9x plus 10, which is what we started with. And those are your factors. So that's called the seesaw method, and it replaces all of these steps. This is decomposition. This is seesaw. So let's take a look at another one. 4x squared plus 16x plus 7. So if I was to use decomposition, I would need all these steps. But what I would do if I was doing this is off to the side on a piece of scrap paper, I would do 4x, bracket all over top of 4. Now see what I've done? I've set up the seesaw. I'm looking for 2 numbers that multiply to give 28, and they're going to add to give 16. So I think that's going to be 2 and 14. So it's going to be plus 2 and plus 14. Now the trick is I got to get rid of that number. It's got to be reduced with multiple of 4 on the top. So I look at the first binomial and I notice that I can take a 2 out of 4 and a 2 out of 2. I look at the second binomial, I notice I can take a 2 out of 4 and a 2 out of 14. I notice that 2 times 2 is 4, divided by 4, bye-bye. And it's going to leave me with a final answer of 2x plus 1, 2x plus 7. Let's check it. 2x times 2x is 4x squared. 14x plus 2x is 16x plus 7. Yoo-hoo! I'm done. And it replaced all of those lines with just the answer, and this off on scrap piece of paper. Let's do the next one. So 3x squared plus 13x minus 10. First, check for common factor. Nothing factors out of all 3 of them. So off on a scrap piece of paper, 3x, 3x over top of 3. 2 numbers that multiply to give negative 30, add to give 13, 2 and 15, negative 2. So it's going to be a negative 2 and a 15, positive. Got to get rid of that 3. It's not going to common factor out of that, but it does common factor out of this. So it's going to be 3x minus 2, 3, x plus 5 over 3. Those 3's reduce, giving me a final answer of 3x minus 2 and x plus 5. So you can see that this is a lot faster. And this is what I do when I'm factoring. It's what I taught my kid to do when she factors. And it's just quicker and easier and nicer in many ways. You can do any of them using the Seesaw method. You can do any of them using the decomposition method. Just keep in mind that you need to factor. You need to do it right. This is probably worth 3 marks, and it's all or nothing, guys. It's all or nothing. All right, guys, that's it. Continue your work.